Let's do another couple of problems. If u is equal to x cube plus y cube plus z cube minus 3xyz, show that x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to 3u. U is equal to, now x cube, let's take it out. So what are we left with? 1 plus y cube by x cube plus z cube by x cube minus 3xyz divided by x cube. Now, as far as the last term is concerned, 3xyz by x cube can be written as x times x times x. So this gets cancelled and we are left with y by z, y by x and z by x. So 1 plus y cube by x cube plus z cube by x cube minus 3 y by x times z by x. This entire thing we can say that it is a function of y by x and z by x. So by Euler's theorem, say we are not going to verify it, we are just going to use it. Since this is homogeneous of degree 3, by Euler's theorem, we have x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to 3u. Now let's do a problem based on Euler's extended theorem. Okay, if u is equal to tan inverse of x cube plus y cube by x minus y, show that x cube dou square u by dou, no, not x cube, x square, dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou u by dou y square, dou square u by dou y square. This is equal to 1 minus 4 sine square u times sine 2u. Okay, let's not stick to inverse trigonometric ratios. Let's bring it to the other side. So tan u is equal to x cube plus y cube by x minus y. Yes. So immediately we know. See, by this time you should be able to look at it, and in your mind itself you should be able to figure out that x cube we take out, x we take out. So x cube by x is x square. So which means that, and their exponents are homogeneous, right? So homogeneous function of degree 2. Okay, by Euler's theorem, what do we have? We have x dou u by dou x plus y dou u by dou y is equal to 2u. Okay, but if you look at this here itself, you know that you have to partially differentiate it. Now x dou by dou x of what? U is what? U is tan u plus y dou by dou y of what? Tan u is equal to 2 tan u. So x, so when we differentiate tan u, what do we get? Sec square u, and then we have to do for u, so dou u by dou x plus y times, okay, so again sec square u times dou u by dou y is equal to 2 tan k. Now sec square is common, so dou u by dou x plus y dou u by dou y is equal to 2 tan u by sec square u. 2 tan can be written in terms of sine and cos, and sec square can be written as, it is actually 1 by sec square, so 1 by sec square is cos square, so this gets cancelled and we are left with 2 sin u cos u, which is nothing but sine 2u. Now since we require dou square u by dou x square, we need to differentiate with respect to x. So x square dou square u by dou x square plus dou u by dou x. See here, x square, x as it is, and we differentiate it once more. This one, dou u by dou x, we get dou square u by dou x square, plus now we differentiate x, and dou u by dou x remains as it is, so x becomes 1 here, plus now y is a constant, but first we leave it as it is, so y dou u by dou y becomes dou square u by dou y. Remember, it has already been differentiated with respect to y, so we are differentiating with respect to x, plus now we differentiate it with respect to we differentiate y. It's a constant, so 0. So don't forget that. We normally don't mention it, but you should know that we actually are doing differentiating of y. Okay, is equal to sine 2u, so cos 2u is, sorry, sine 2u is cos 2u when we differentiate, then 2u becomes 2, and 2 du by dou u by dou x. Okay, now let's x times dou square u by dou x square plus y dou square u by dou x dou y is equal to cos 2u, 2 cos 2u. Now this we bring it to the right hand side, so, and we take out dou u by dou x common, so we are left with 1 dou u by dou x, differentiate with respect to y. So x as it is, dou u, dou square u by dou x is already there, so dou y, plus now we are differentiating with respect to this, with respect to y, so it's a constant, so this becomes 0, plus y dou square u by dou y square plus 1 times dou u by dou y is equal to sine 2u becomes cos 2u times 2 dou u by dou y. Okay, rearranging it, dou square u by dou y dou x plus y dou square u by dou y square is equal to cos 2u, 2 comes here, this comes to the right hand side, it's common, so minus 1 times dou u by dou y. Okay, so now what do we have to do? Remember, multiply this with x, multiply this with y, and then add. Yes, okay, so let's multiply So this becomes x squared dou square u by dou x square plus xy dou square u by dou x dou y plus. So we have multiplied the left hand side with x. Let's add the left hand side of the other one after multiplying it with y. So this becomes xy dou square u by dou y dou x plus y square dou square u by dou y square is equal to, now the right hand side, 2 cos 2u minus 1 x plus dou u by dou x plus y times 2 cos 2u minus 1 dou u by dou y. Okay, so let's see. Now here, if you notice, this is dou x by dou x dou y, and this is dou y dou x. But remember, they are both equal. The order of derivation is not relevant. So they both are equal. That means these two are like terms. So which means x square dou square u by dou x square plus 2xy dou square u by dou x dou y, any one we can choose, plus y square dou square u by dou y square is equal to, now here if you notice, 2 cos 2u minus 1 dou u by dou x is common, right? So 2, but let's, in dou u by dou x is not common because here it is dou x, here it is dou y. 2 cos 2u minus 1 is common. So 2 cos 2u minus 1 times x dou u by dou x plus y dou u by dou y. Now we already know that this is equal to what? This is equal to sine 2u. Sine 2u. So we are very close. We are very close to what we have to show. Where is that? Show that. 1 minus 4 sine square u sine 2u. Okay. So cos 2u. Now here we have to remember the identities. So 2 cos 2u can be written as 1 minus 2 sine square u minus 1 sine 2u, which is 2 minus 4 sine square u minus 1 sine 2u. 2 minus 1 is 1. So 1 minus 4 sine square u times sine 2u, which is what we have to show. So as you can see, take it step by step. It looks complicated, but as when you do step by step, each step makes sense. Again, as you notice, the calculus part is very minor. Major part is your other topics like algebra, like arithmetic, like trigonometry. Okay, now practice. Bye for now.